Questions 1 through 4 on the 2012 Grade 12 Euclid Math Contest. John buys 10 bags of apples, each of which contain 20 apples. If he eats 8 apples a day, how many days will it take him to eat the 10 bags of apples? Well, there's 10 bags, and each has 20 apples in it, so there's a total of 200 apples. And each day, he is eating 8 of them, so you take 200 and divide by 8, and that gives you 25 days. So 25 days is the amount of time that it takes him to eat all the apples in the 10 bags. Determine the value of sine 0 all the way to sine 360. Well, the sine of 0 is just 0. And the sine of 60 is root 3 over 2. The sine of 120 is also root 3 over 2. The sine of 180 is 0. The sine of 240 is negative root 3 over 2. The sine of 300 is also negative root 3 over 2. And finally, the sine of 360 is 0. So those are our 7 values, and if you add them all, you'll notice this cancels with this and this cancels with that, so you just left with 0, and that is the answer to part B. A set of integers has a sum of 420 and an average of 60. If one of the integers is 120, what is the average of the remaining integers in the set? So we have a bunch of integers, a plus b, all the way up until some number. I don't know what that is. And that, along with this 120, have a sum of 420. So that means that that initial group of integers, a plus b dot dot dot, that has a sum of 420 minus 120, which is 300. Correct? And then they tell me that the average of that original set is 60. So that means this whole thing right here, if you were to take that top set and divide by the total number of integers, which I don't know, so I'll just say is n, that is equal to 60. So basically, if I took all those numbers, a plus b dot 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 plus 120, and then divided by the total number, they're saying that is equal to 60. But we know this sum right here is 420, so I can substitute that in. 420 over n is equal to 60. And then cross multiply, and you get 420 over 60 is equal to n, and that gives me a value of n being equal to 7. So now they're asking, what is the average of the remaining integers in the set without that 120? Okay, so that means we are just going to use these numbers here. So it's going to be a plus b dot dot dot, and then divide by, this time not 7, because we're not going to include that 120, so we divide by 6. Well, a plus b dot dot dot, we just figured out was 300. So it's 300 divided by 6, and that, of course, is 50. So that's the answer. If ax plus ay is equal to 4, and x plus y is 12, what is the value of a? Well, in the first equation, you can factor out an a, and you get x plus y is equal to 4. And then x plus y is equal to 12, so we can substitute that in. And then therefore, a would be equal to 4 over 12. And 4 over 12 in lowest terms is 1 over 3. So that is my value for a, 1/3. If the lines with equations 4x plus 6y equals 5 and 6x plus ky equals 3 are parallel, what is the value of k? Two lines are parallel if they have the same slope, so we have to first get these lines into this format, y is equal to mx plus b, where m is the slope. So the first one is 4x plus 6y is equal to 5, and therefore 6y is equal to minus 4x plus 5, divide through by 6, and we get y is equal to minus 4 over 6x plus 5 over 6. So this is the slope of the first line. The second line is 6x plus ky is equal to 3. Bring everything over to isolate for y, and we get ky is equal to minus 6x plus 3. Divide through by k, and we get minus 6 over kx plus 3. This slope is minus 6 over k. Now this slope and that slope have to be equal in order for these two lines to be parallel. So that means minus 4 over 6 must equal minus 6 over k. Cross multiply, and we can drop the negatives, and then cross multiply, and you get 36 is equal to 4k, and then divide through by 4, and that gives you a value of 9 for k. Determine all pairs xy that satisfy the system of equations. So x plus y is 0, and x squared minus y is 2. So many ways of doing this. I'll just add them, and if you do, I get x squared plus x is equal to 2. Put everything on one side, and we get x squared plus x minus 2 is equal to 0. And if we factor this should factor x, 2, 1, positive, negative. So that means x is equal to either negative 2 or positive 1. Now we have to figure out the pairs, so I have to figure out my y values. If x is equal to negative 2, substitute it back into either of those, and you get y is equal to positive 2. If x is equal to positive 1, then substitute that value of x into here, or either one, and you get y is equal to negative 1. So my pairs xy are negative 2, 2. That's the first one. And another one is 1, negative 1. And there you go. Negative 2, 2, and 1, negative 1. A 200-gram solution consists of water and salt. 25% of the total mass of the solution is salt. How many grams of water needed to be added in order to change the solution so that it is 10% salt by mass? Well, initially you have 200 grams of solution, and 25% is salt. So 25% of 200 is 50. So that's how much salt we have in the initial solution, 50 grams. And that means the remaining 150 grams is water. Now what they want you to do is add a certain amount of water, so plus x, so that now when you take the ratio, it will be 10% salt. So we now have 50 over 150 plus x, and this is what has to equal 10%. But actually it's not 150, be careful. It's actually the total, right? We have to put it over 200 plus x. Okay, so that is equal to 10%, which is 0.1. So now we cross multiply, and when you do, you get 50 is equal to 20 plus 0.1x, and therefore this is 30 is equal to 0.1x, and therefore x multiply both sides by 10, and you get 300. So 300 is really what that x is. So we have to add 300 grams of water in order for this solution to be 10% salt. The correct formula for converting Celsius temperature to a Fahrenheit temperature is F is equal to 9 over 5C plus 32. To approximate the Fahrenheit temperature, Gordy doubles C and then adds 30 to get F. If small f is less than big F, the error in the approximation is big F minus small f. Otherwise, the error in the approximation is small f minus big F. For example, if big F is 68 and small f is 70, the error would be 2. Determine the largest possible error in approximation that Gordy would make when converting Celsius temperatures with Celsius between -20 and +35. So we can make a quick table and see what kind of values we get. Now, hopefully we don't have to do all of these, right? Because that would be very time consuming. So hopefully we'll get some sort of a pattern and see what happens. So this is my Celsius, and this is my Fahrenheit F, which I get from this formula right here, which is 9/5C plus 32. And then I get my approximation, small f, and that approximation is obtained by just doubling C and then adding 30. All right, so that is my small f and my big F, and then we'll calculate the error. And the error just looks like F minus F, the absolute value of it, regardless of whether it's negative or positive. We're just looking at the positive value. Okay, so let's start. Our range is between -20 and +35. So let's start with -20. And when you do, and you put it into this formula here, you get -4. When you put it into this formula, you get -10. So the error is obviously 6. Okay? So that's how we're going to do this. So let's keep going. Let's jump a little bit. Instead of doing -19, -18, and all that, let's jump to -15. That gives us an idea of what this is going to look like. So now my big F will be 5, and my small f will be 0. So now my error looks like it is 5. Okay? Don't see much of a pattern yet, but I have to do a few more. How about if I do -10 for Celsius? This gives me now 14, and small f becomes 10. So my error now is 4. All right, it's going down. Let's try 5, -5, and then 0, and then we'll see what happens with after that. Well, if it's -5, we get 23, and then for f, it will be 20. So that will be 3. 0 is pretty easy. It'll be 32 and 30, and then that's 2. So it looks like it's going down. But I've got to also figure out what it's going to be for the other ones. So I hope we don't have to go all the way up to 35, but let's just see. 35, let's try 25, and 15. Let's see what these numbers get. If I do 15, that's what I'm starting with. I get 59 and 60, so that's a difference of 1. If I get 25, I get 77 and 80. That's a difference of 3. And 35, which is the absolute end of the line for us, it's 95 and 100, and that's a difference of 5. So it looks like it initially started at 6, the error, and then it kind of went down to 1, and then it went back up to 5. So the largest possible error is 6. And that's a pretty decent way of approximating it, instead of having to do every single value of C, like -19, -18, and so on. The horizontal line y is equal to k intersects the parabola with the equation y is equal to 2 times x minus 3 times x minus 5 at points A and B. If the line segment AB is 6, what is the value of k? So we have 3 and 5 as the points of intersection of this parabola, and it's going to look something like this, right? It's going to pass through 3 and 5 like that. And then we have this horizontal line, y is equal to k, that's passing through that parabola. And the points that it intersects are A and B, like that. And we are told that distance is 6. From there to there is 6. So we have to find the value of k, where this is the line y is equal to k. And then the equation of the parabola is right here. Okay, well, A to B is 6. So if this point, let's say A is, say, A and then k, the y coordinate will be k, and this is b and then k, and that means basically that b minus a is 6. So b is equal to 6 plus a. So this coordinate is really a plus 6k. All right, so now we have to take this equation and work with that. So we know that these 2 points are on that equation. So we can substitute them in. The first one, for y is equal to 2 times x minus 3 times x minus 5. Put in ak. So we got k for y, and then for x we have a. Like that. And then our second equation, or the same equation actually, but second point I should say, is that one. A plus 6 in k, that also satisfies that equation because it's also a point on the parabola. So that means k is equal to 2 times a plus 6 minus 3 times a plus 6 minus 5. So if I simplify this a little bit, it'll be 2 times a plus 3 times a plus 1. Okay, well k equals that, so let's set them equal to each other. So that means 2 times a minus 3 times a minus 5 is equal to 2 times a plus 3 times a plus 1, right? So divide through by 2, and then let's expand this. So this becomes a squared minus 5a minus 3a plus 15. And this side is a squared plus a plus 3a plus 3. So the a squareds disappear from both sides, and all you're left with is minus 8a plus 15 is equal to 4a plus 3. Put everything on one side, collecting like terms, and this will give you 12 is equal to, add 8a to both sides and get 12a, and therefore a is equal to 1. Great. So now I can figure out my value for k. I can substitute it into either one of these to get k. If I do, let's put it in here. That means k will be equal to 2 times 1 plus 3 times 1 plus 1, and that is 2 times 4 times 2, and that is 16. So k is equal to 16. Determine 3 pairs AB of positive integers for which this expression is a perfect square. Well, they have broken it up into an interesting way. I'm not sure why, but I guess the first thing we have to do is add them. So if we do this part, if you add it all up, it becomes 45a. And then this part, if you add it up, it becomes 90b. And they want this to be a perfect square. Okay, well, factor out a 45 first. That gives me a plus 2b. And then the 45, let's break it up into its prime factors. It'll be 3 squared times 5. And then we have this a plus 2b. Okay, now we can discuss this. In this format, it was probably not going to happen, but in this format, it's going to be a little bit more easier to understand. How to make this now a perfect square? Well, this part is already a perfect square. 3 squared, obviously. So we have to somehow now concentrate on these terms. If, for example, this is a 5, then 5 times 5 will be a perfect square. So let's do that. Let's concentrate first on making that a 5. If that is true, then this will be a perfect square. It will basically become 3 squared times 5 squared, and as you can see, that is 15 squared. So it is indeed a perfect square. So my task is to get a plus 2b to equal 5. And a and b are positive integers, so I think I can do that without too much trouble. If a is equal to 1, then that would mean 2b is 4, so that means b is 2. So there we go. I've got one such ab. And then I think I can get one more here. If a is 3, then that means 2b will be 2. That means b will be 1. So 3 and 1, that's another AB. But they want 3. Okay, well, 1, 2, and 3, 1 are definitely, pairs, but they want one more. Okay, if they want one more, then I've got to go back to the drawing board and look at this a little bit differently. In particular, this equation. So I'm going back to 3 squared times 5 times a plus 2b. Well, there's many ways at this point to get the third pair. Any way you'd like to do this is fine. Let's just make it easy. If this, for example, is 5 times a perfect square, like 4, that would do it, correct? Because this would now become 3 squared times 5 squared times 2 squared, and that is 30 squared. So now my task is to make this equal to 5 times 2 squared. And like I said, there's an infinite number of ways of doing this, a third pair. But just make it easy for yourself. A plus 2b is now 5 times 2 squared, which is 5 times 4. So that means a plus 2b is 20. Well, if a is equal to 2, then that means 2b was 18, and that means b is 9. So this is another one. 2, 9 would also work. And I think that's good enough. So here's your third pair. So I've got this one, and this one. And like I said, there's an infinite number. So whichever ones that you find, as long as you end up making this expression a perfect square, it should be valid.